Today we'll be going over section 2.4, which is writing linear functions. So just so you're aware, as you're going through this lesson, it will periodically stop and give you a question to answer on your own that deals with the material that we just went over. So this is a way for you and me to kind of see how well you're understanding the material. If you find that you can't answer the question or you're stuck, feel free to rewind the tape and look at the example over again. And you could also use your textbook as a resource. Okay, so again, section 2.4 is writing linear functions. Now if you go back and think about section 2.3, we talked about slope-intercept form, which is y equals mx plus b. Now, slope-intercept form lays everything out pretty nicely for us. Okay, we know that m is our slope and b is our y-intercept. Okay, so when you have an equation that's written in slope-intercept form, you can really you know exactly the behavior of the graph. So this form is very helpful. Okay, now x and y, now those vary depending on what point on you can plug in any point on your line, and again there's infinity points because the line goes on forever. You can plug in any of those points, the coordinate x and y, and that equation will be true, okay, if it falls on that line. So in section 2.3, you graph lines when you were given the slope and y-intercept. So in this lesson, we're actually going to write linear functions when you were given graphs of a line or problems that can be modeled with a linear function. So in the next example, what I want you to do is write the equation of the graphed line in slope-intercept form. So we have to think back to what we know. Okay, I need to know, well, first I know that slope-intercept form is y equals mx plus b. I need to find my slope, and I need to find my y-intercept. So the y-intercept is exactly what it sounds like. It's where on my graph does my line intercept the y-axis. So that would be this point right here, which looks like it is positive 1. So b is 1. Now we have to figure out, well, what is our slope? So in order to do that, we have to look at our point here and say, well, how do I get to the next point on my line, or any point on my line? Okay, so I'll check this point right here. So as I count, it's going up or rising, 1, 2, 3, positive 3 because it's going up, and up is positive. Now I'm going 1, 2, 3, 4 to the left, and 4 is negative. So since it's rise over run, okay, m, or the slope, would be positive 3 over negative 4. So my slope is negative 3/4. So now all I have to do from this point is plug in negative 3/4 for m and positive 1 for b. And that's the equation of my line. So we have to figure out, well, how can you actually calculate slope? Now, to calculate the slope, okay, we can use this formula here, which you've probably seen in Algebra 1. So to find the slope when you're given 2 points on a line, the slope is the ratio of the difference in the y values to the difference in the corresponding x values, or as you more commonly know as rise over run. So algebraically, if we look right here, okay, x1, y1, and x2, y2, those are just any point, okay, any two sets of points. The slope formula is y2 minus y1, which is the change or the difference in y values over the difference in our x values, which is x2 minus x1. So here graphically you can see, here's my rise, okay, those are my y's. So to find the distance of my y's, I subtract y2 minus y1, because that's my vertical distance, and then I divide that by x2 minus x1, which is my run, or my horizontal distance. So let's try an example. I want to find the slope of a line that goes through the point negative 1, 1, and 2, negative 5. So if we look at that, Okay, I'm going to plug into my formula, which is y2 minus y1 over x2 minus x1. Now I know a lot of you may memorize this formula, but it's important to know what it actually means. Okay, we know that the slope is actually the steepness of our line or our rate of change. So it's important to know what you're actually doing in this formula. So I'm going to take my y2, so this is x2, this is y2, this is x1, this is y1. I'm just going to plug in. So negative 5 minus 1, which tells me the difference of my vertical distance, and x2, which is 2, minus negative 1. Now this is the most common mistake that I see. Okay, when you're subtracting a negative, okay, it's very easy to mistake that and forget that when you subtract a negative, it actually turns into a positive. So if we continue with this, okay, negative 5 plus negative 1 gives me a negative 6. 2 plus 1 gives me a 3. Okay, so that simplifies to negative 2. And that is my slope. So the steepness, or the rate of change of my line, is negative 2. Okay, so here's a different type of example. Okay, we want to find the slope of the line given this table right here. They just give us a table of values. A lot of times when students see this table, they lose track of they don't really realize what information they're getting. What they're given in a table, okay, this is a linear, since they're finding the slope of this line, they're making the assumption that this is a linear relationship. So what these are, so if we look here, we have x is 4 when y is 2. So that's actually a coordinate pair. I can go here. This is another coordinate pair when x is 8, y is 5. When x is 12, y is 8. And when x is 16, y is 11. So these are all points on our line. They're giving us a lot of information here. So what we can do is we can just find the slope of the line by plugging that right into our formula. So then you might ask yourself, well, what 2 points can we use? Okay, and I'll tell you, it does not matter what 2 points you use. I could use 4, 2 and 16, 11. I could use 4, 2 and 12, 8. I could use any combination of 2 points, because in a linear relationship, the ratio, which is our slope, will always be the same. So let's choose any 2 points. I'll choose the first two. Okay, so I'll let 4 be x1, y be, and 2 be 4 is x1, 2 is y1, 8 is x2, 5 is y2. So I can plug that into my formula. 5 minus 2 over 8 minus 4. And that gives me 3 over 4. Now just to kind of demonstrate to you, I'll use the point 8, 5, and 16, 11. So I'll try this formula again. I'll do 11 minus 5 over 16 minus 8. And that gives me 6 over 8. Well, I get 3/4 and 6/8, but actually 6/8 can simplify to 3/4. So again, no matter what combination of points that you use, it will always give you the same ratio or the same slope. Now, the next question I have for you is, what if I switch my points? What if I wanted to use, so let me go back here. What if I wanted to use, I go back to my original example, and what if I plugged in 8? What if I said, well, I want 8 to be x1 and 5 be y1 and 4 be x2 and 2 be y2? Now this is not going to affect your answer at all. It doesn't matter if you switch the coordinates y2 and y1 and y2. Doesn't matter which one you do first, as long as you use the same order for your x's as you do your y. So what I mean by that is, if I did 2 first, I'm looking at this same example, but I'm going to switch this around. So I'm going to do 2 minus 5 over 4 minus 8. Right, 2 minus 5 gives me a negative 3. 4 minus 8 gives me a negative 4. So really this still is going to simplify to a positive 3/4, because a negative divided by a negative is positive. So you're still going to get the same answer. So if I do y2 minus y1 over x2 minus x1, that's the same thing as if I do y1 minus y2 over x1 minus x2. So as you see, it only matters, when I use, this has to be the same point, and this has to be the same point. Okay, I can't switch this around. I can't say, well, y1 minus y2 over x2 minus x1, because that won't match up. You'll get a different answer. Okay. So my next question that I have is find the slope of the line of this graph right here. In case you can't see it, we could blow it up a little bit. So we have a y-intercept is the first thing we want to look for. Or before we find y-intercept, I'm sorry, we're just finding the slope, not the equation. So what I can do is I can pick any single 2 points on my line. So I'll pick this point right here, because it's my y-intercept, so why not? And that point is 0, -2. Then I'll pick a point right here, which is 2, -2. And I'm going to plug this into my slope formula. -2 minus -2 over 2 minus 0. So -2 minus a negative becomes plus positive, so I get 0 over 2. What does that mean? That means my slope is 0. A lot of students get thrown off by this, but really, you're allowed to have a slope of 0. A slope of 0 means it's a vertical line. I'm sorry, a horizontal line. Okay, that's what it means. When you have a slope of 0, it's always going to be a horizontal line, and the equation of your line depends on where it crosses the y-intercept. So we're going to move on to a different form. Okay, we learned about slope-intercept form. Now we're going to discuss point-slope form. And you may have seen this in Algebra 1 before. Okay, the equation of a line with a slope of m and any point on the line x1, y1 is y minus y1 is equal to m times the quantity of x minus x1. So let's look at an example. Okay, in slope-intercept form, I want to find the equation of the line. So again, I'm given this table, which all that means is that these are coordinates. So what this means is that -8, -5 is on my line, -4, -3.2, I'm sorry, 3.5 is on my line, 4, -0.5, and finally 8, 1. All these points lie on my line. Now I want to find the equation of this line. I could easily graph these points and draw my line, but I want to know, well, what's the actual equation? So the first thing I have to do is I need to find my slope. Okay, so I'm going to use any 2 points. Logically, to me, it makes sense to use this point and this point, because just to make my life easier, I'll use just whole numbers. So when I find my slope, I use 1 minus -5 over 8 minus -8. So 1 plus +5 gives me 6. 8 plus +8 gives me a 16. So my slope is 3/8. Okay, so I have m. So there's 2 ways to do this, really. I could use the slope-intercept form, and I have m, and I just have to find b, or I could use the point-slope form. And I'll show you both examples here, just so you can see both examples. So again, I have my slope is 3/8. Let me just shrink this so we have a little bit more room. Okay, so I'm going to first do the point-slope form. I know that m is 3/8. I'm just going to plug that right in. Now what I'm going to do, I need to plug in a point for y1 and x1. So that's simple. I'm just going to plug in any single point on my line. I'm going to plug in 8, 1, just because it's a whole number and that's just the one I want to choose. You could choose any other point if you would like. So I'm going to plug in 1 for y1, and I'm going to plug in 8 for x1. I'm just going to simplify. Okay, I'm going to distribute my 3/8. 3/8, just a side note, 3/8 times 8 over 1 is 3. Okay, just so you see where my math is coming from. So again, this is going to be a minus. So once I distribute my 3/8 to my -8, it's going to be a minus 3. And my last step is to just add 1. And this is my equation. Okay, so that point slope form makes it pretty easy. Everything's laid out. I just have to simplify. So now what I want to do is I would like to use the slope-intercept form. Now I have y equals mx plus b. What I have right now, after I pick 2 points, I know that m equals 3/8, so I'm going to plug that right in. Now I just need to know, well, what's b? Okay, so in order to find b, what I'm going to do again is I'm just going to plug in any single point that I want here. And again, I'm just going to use 8, 1. So I'm going to plug in 1 for y and 8 for x. Okay, so all I did here, again, was plug in, this was my y coordinate, this is my x coordinate. And now I'm going to simplify and solve for b, and then plug right back into my original equation. So 1 equals 3/8 times 8, again, is 3, plus b. Subtract 3 from both sides, and I get b equals -2. So really, I'm going to plug in that -2 right back in here, and I get y equals 3 over 8x minus 2, which is the same thing we got in our other example. So again, both, you could use either method and they'll both get you the same answer. So it's whatever you prefer. Alright, the next example, we have a little word problem here. So we have, the table shows the rents and selling prices of properties from a game. Express the rent as a function of the selling price. So let's diagnose what that means. I'm going to express the rent, so I'm making my function that expresses my rent. So I'm going to let y be rent, and I'm going to let the x be the selling price, because it's a function of the selling price. So again, the first thing I have to do is I need to find the slope. So I'm going to pick any 2 points. Okay, my selling price is x, my rent is y, so this coordinate is 75, 9, and I'll choose the next one down, which is 90, 12. And I'm going to plug this into my formula. 12 minus 9 over 90 minus 70. I'm sorry, 75. Alright, I'm going to have to show this over again. So we have 75, 9 and 90, 12. So I'm going to plug this in. So again, y is my rent. X is my selling price. So my slope of my function is 12 minus 9 over 90 minus 75. So I end up with 3 over 15, which is 1/5. There's my slope. Okay, now I can use the same method that we just went over in the last example. I'll use the point slope form. Okay, so y minus y1 equals m, which we know is 1/5, x minus x1. I'm going to pick any point. I'll use the first point because it's right there. So y minus 9 equals 1/5 times x minus 75. And I'm going to simplify. So I'm going to distribute my 1/5. 1/5 times -75 is 15. So minus 15. And I'm going to add my 9. So I get y minus 9. I'm going to add my 9, so I end up with y equals 1/5 x Negative 15 plus 9 is a minus 6. And that's a function that expresses my rent, or y, in terms or as a function of my selling price. So, next thing I want to talk about is, well, how do we know if lines are parallel or perpendicular? And here's how you can tell. The slope will tell you a lot of this. So let me blow this up so you can see this a little bit better. So if both slopes are defined, the slopes of parallel lines are equal. So if two lines have the same slope and they have different y-intercepts, then they are parallel. If they have the same slope and the same y-intercept, that means they're just the same line. Okay, so if they have the same slope, then they are parallel. The slopes of parallel vertical lines are undefined. So again, we talked about how vertical lines, horizontal lines, they have a slope of 0, while horizontal lines are undefined. So here's an example, a little picture of two lines that are parallel. Okay, we have these two lines here. The equations are written here. Y equals 2x plus 1 is the red line, and the blue line is y equals 2x minus 3. So they both have a slope of 2, so they're parallel. Okay, perpendicular lines, if both slopes are defined, the slopes of perpendicular lines are opposite reciprocal. Okay, if they're opposite reciprocal, it means that the product is negative 1. So if you multiply the slopes together, you should get negative 1. A vertical line and a horizontal line, they are perpendicular. Okay, so here's an example. We have the red line is y equals negative 3/2 x plus 4. So the slope is negative 3/2. The blue line is y equals 2/3 x minus 3. So the slope of that line is 2/3. Okay, so the opposite, meaning the red line is negative, the blue line's positive, so they're opposites. Reciprocal means you just flip the fraction. Okay, so 3/2, if I flip that, 2 goes into the numerator, 3 is in the denominator, so you get 2/3. If I were to multiply their slope, as you can see here, you get negative 1. So those lines are perpendicular. So write the equation of the line in slope-intercept form. A line that is perpendicular to negative 3/2 x minus 1, and it goes through the point 9, negative 2. So the first thing I want to know is, well, what's the slope of my line that I'm trying to find? Well, if the slope of this line is negative 3/2, I have to have the opposite, so it's going to be positive, and I'm going to flip it, so it's going to be 2/3. So y minus y1 equals 2/3 x minus x1. Now I had to finish the equation, so I need to get it in slope-intercept form, so I'm going to plug in the point 9, negative 2. So I'm going to plug in 9 for x1 and negative 2 for y2. I'm sorry, x1 and y1. So I'm going to plug in y minus negative 2 is equal to 2/3 x minus 9. And I'm just going to distribute 2/3 x minus 2/3 times negative 9. This becomes negative 6. And the last step, I'm going to subtract the 2. And when I do that, I get y equals 2/3 x minus 8. Alright, so that's all the examples I have for today. Hopefully you understood that pretty well. Feel free to, watch the tape over again. Hopefully you took notes going through this, and we will get a little bit more practice and do some examples first thing tomorrow in class.